Hi guys, in this video we are going to work out this exercise right here. The exercise is stipulating that relative to an origin O, the position vectors of points A and B are given by the vector OA with 3p, 4 and p to the power 2, and OB with minus p minus 1 and p squared. So what we want to do here is to find the value of P for which the angle OAB will be 90 degrees. And we will find the unit vector in the direction of the vector BA for the case where P equals 3. To answer the first question, we will proceed by doing the scalar product of the two vectors OA and OB. So that we will have the scalar product of them will be OA times OB, and this is going to be, we're going to multiply the element of OA and OB. This is going to be give us 3p times minus p. This is minus 3p squared. 4 times minus 1 be here minus 4, and p to the power 2 times p to the power 2 will give us plus p to the power of 4. And we can also arrange this in a different order by saying that it is p to the power of 4 minus 3p to the power of 2 minus 4. And we know that p to the power of 4 is p to the power 2 times p to the power 2 minus 3p times p minus 4 times 1. So this is giving us here p to the power 2 minus 4 times p to the power 2 plus 1, and we can work this out equals to 0. And this is going to give, we know that if you have a 2 product equals to 0, it definitely means that either p to the power 2 minus 4 equals to 0, or p to the power 2 plus 1 equals to 0. And we subtract minus 1 to this one here. This case is going to be impossible, okay? And we still have this one to work out. So we're going to say that p, we add plus 4 to it equals to 4, and then we square root it. This is going to give us p equals to plus minus 2. And these two values, p equals to minus 2 and p equals to 2, are actually the values of P for which the angle OAB has 90 degrees. Now, to answer the second question, we'll first find the vector BA. Okay, and we know the vector BA is equal to the vector BO plus the vector OA. Okay, and the vector BO is going to be the opposite, the inverse vector of this one here. It means that we're going to have BO will be here, so minus everything, that would be P, and that would be 1, and that would be minus P to the power 2. And then of course plus the vector OA, and the vector OA is 3P, 4, and P to the power of 2. And this is going to give us here p plus 3p would be p plus 3p, 1 plus 4 would be 5, and then minus p squared plus p squared would be 0. Now if we consider the case where p equals 3, the vector BA will give us, we replace p by 3 here, this is going to be 3 here, and plus 3 times 3, 9, this is going to be 12, and then you have 5 here, and 0. And we know that to find the unit vector, we will have to use this formula here, 1 over the absolute value of BA, or the distance, and BA. We already have BA, the vector BA, so we still have to find the absolute value of BA. And the absolute value of BA, or the distance BA, equals to the square root of, we have here 12 to the power 2, or 12 squared, plus 5 squared. And this is going to give us the square root of 169, which is 13, or plus minus 13. But we're only going to consider the positive value here, so we're going to say it is equals to 13 because it is an absolute value. So we're taking 13 instead of a minus 13. We're not taking minus 13. So our unit value, let us put it u, would be then 1 over 13 times the vector BA times will be here 12, 5, and 0. And that's the unit vector in the direction of BA in the case where P equals to 3. Okay, so once again, in this video we were asked to find the values of P for which the angle OAB is 90 degrees. To do that, we had to use the scalar product of OA and OB. It means that multiplying the value of OA with the value of OB. That's what we have here. 3P times minus P gives us a minus 3P to the power 2 minus 4 times minus 1, and P squared times P squared P to the power 2. And then we rearrange it in a decreasing power, and then we know that P times P to the power 2 times P to the power 2. So we just expand it to be able to factor it, and the factor of it is P squared minus 4 times P squared plus 1 equals to 0. We work it out and obtain P equals to plus minus 2, and these are the value for which the angle AOB is 90 degrees. And for the second question, we had to find the unit vector in the direction of BA in the case where for the case where P equals 3. First of all, we found the vector BA, and the vector BO equals to BO plus OA, and BO is the inverse vector of OB. So we would multiply by minus 1, and minus will disappear on these first two terms and come to the third one, because we're multiplying by minus 1 because this is the inverse vector of this one, plus OA, which is this vector, and plus OA we add them together and replace P by its value 3 given here. So we will obtain 3 plus 3 times 3, this is 12, and then 5 and 0, and we obtain our vector BA. And using the formula of a unit vector in this case, which is 1 over the scalar product over the absolute value or the distance times of BA times BA, the vector. So we found VA, the absolute value of BA, which is plus minus by square rooting here plus minus 13, but because it is an absolute value, it definitely means that we're going to take the positive value. And then we used all those to write our unit vector U, which is equal to 1 over 13 times the vector BA. And this is how you can work it out. Okay, so thank you for watching again, guys. Until next time, bye bye.